In this video, I will show you a tool that I've been working on, which is a web simulator. So basically a tool where you can, for example, simulate a buck converter and define the controller and get some output results afterwards. This is one for the buck converter, but I also have for other converters as well, and I will continue adding more converters. So here we have the buck converter. I can just go through it a bit. So here we have a schematic of the buck converter. So you're not able to change the schematic, but I have three different options. So one is the standard, then bidirectional. There's no difference between them actually. And then we have the average model. And then you can define or change the parameters inside. And then you can change the parameters related to the buck converter itself. And also add some measurements. For example, I can add a voltage measurement. For example, if I want this, which is the voltage over the diode, then we have that one here. And then we have the simulation time, the time step, and where you want to start the plot. And here we have the controller. So I have two different controllers. I have one voltage mode controller, where you only have a voltage controller, and then you have the PWM, and then the gate signal that you find goes right into the buck. So the gate signal goes in here. And then we have a cascade controller, which is a voltage controller in the outer loop and the current controller in the inner loop. And here we have the different C codes where you can define the controller. So if you're not familiar with C code, I highly recommend that you ask AI to translate it for you and follow the correct syntax. And it's not very complex if you just look into it a little bit. So here we have the parameters that we've defined, the voltage controller, current controller, PWM, and then this is something else. This is a Python script where you can add, for example, if you want a variable reference voltage on the output, then you can define the signal here in the Python script. So for example, here we have a reference signal that is on average 12, but oscillates here. Then we can just write vref, then it will automatically be added. And we can do this to all of the parameters here. And we can even use these in the script itself. And then we can try to run it. So you see that now we've run it with a variable voltage reference. So you can see that it goes up and down. So I can just make this dashed so you see it better. So you see that it almost follows the voltage actually up front. But yeah. And then we have this plotting tool where you can zoom in as you want. And you can see that it's the precision is not very good right now, but we can add smooth curves to get a smooth. And I will also add an option so you can change the sampling frequency of the plot, because the sampling frequency of the plot is much smaller than the actual sampling frequency here that we defined here. They are not related. And so you can add whatever curves that you want and even add expressions. For example, if I want the power, I can write IL times V out. So this would be the output power. So you can see that it looks like this. And then you can decide which grade you want it in. So let's say that I want it in a second, or you can add multiple subplots. So we have 3 here. Let's add this to the third one. So it's alone. And then we can add expressions as well. So the average, we can take the average of this. And then you can see that we have 56.5 on average for the power. And there's also a possibility to add sweeps. For example, if you want to see how the buck converter changes when we change the inductance. So here we just define from 50 microhenry to 150 microhenry. And then we do 5 steps linearly. So then we can run the sweep. And in order to see the results, we need to add L as a drawer. So here you add it, and then you can swipe to see the difference. So you can see that the lower the inductance, the larger the ripple becomes. You can see that the ripple here changes. So we can zoom in here to have a look. You can see that the lower it becomes, the larger it becomes. So those are basically everything that you can do here. There are many things that I haven't told you yet. You can add another plot, so you have two plots instead. So you can see that here's V out again in just a single plot. And then you can add cursors to do some measurements. So we have measurements here. So here are the values, and then we have the time and the values. And then you can add, for example, the mean if you want that, or you can add RMS. You can change these. So let's say the integral. You can do that as well. And the reason why we have two different values here, because we have a sweep on the inductor. So the values are in between 12.6 and 12.7. So these are independent of L, but if we add L, then you can see that these changes here. Now we only have one value because we've defined an L. And actually, if you zoom in when we've not defined L, you can see that we have an area, and that is because there are multiple possible solutions. So we have basically drawn the bottom and the maximum L, and then we've colored the area in between so that you see the range in the values that we can get. And I think these are most of the things that we have. So we also have a boost converter, which you can also try. And then we also have the ability to load. For example, we have a buck comparison where you can load sessions. So I have one session which is related to the boost course, which I think will be global when I launch this. Then we can try to run the sweep and see the results. And then the other ones are not ready, but they are coming pretty soon.